Okay, we are going to wrap up this last section in chapter 11 with just trying to help us decide which type of chi-square test we should run. We're not really going to, in this video, go through any full-blown examples, but more so just distinguishing which type of test should be run based on the way the problem's worded. And so in this problem, it says secondhand stores. We have a study of customers' attitudes towards secondhand stores, interviewed separate random samples of shoppers at two secondhand stores of the same chain in two different cities. They recorded the gender of the subject. See the table to the right. So our options here are either a chi-square test for homogeneity or a chi-square test for independence. Remember, the main difference between these two things is how the data is being collected. If it's being collected through separate samples from different populations, different samples, it's going to be a chi-square test for homogeneity. If it's being selected from one sample and we're comparing a couple of different categorical variables, that's when it's a chi-square test for independence. Well, you can see here, we've got the cities, we've got the gender here, but what we want to focus on is the fact that they interviewed people from separate random samples of shoppers. And so that's where we're going to say that for this particular example, we would be doing the chi-square test for homogeneity. Okay, now the main difference of these two tests is one, how the data is collected, two, how you draft your null and alternative hypotheses. The rest of the significance test is executed in the exact same way, even down to choosing the same feature on the calculator. Simply the test is called chi-squared test. Okay, so the null hypothesis for this particular example is to say there is no difference in the true gender distribution of shoppers at these stores in the two cities versus there is a difference in the true gender distribution of shoppers at these two stores in these two cities. Okay, let's go ahead. We're going to pass over this part here at the bottom. Let's read this problem, see if we can decipher which type of test we should run. And again, we're not going to go through this entire thing. A study followed a random sample of 8,474 people. Okay, so right here, one sample. Okay, one sample. Normal blood pressure for about 4 years. All the individuals were free of heart disease at the beginning of the study. Each person took the Spielberger Trait Anger Scale test, which measures how prone a person is to sudden anger. Researchers also recorded whether each individual developed coronary heart disease. Is there an association between the development of CHD and anger? Here's a two-way table that summarized the data. So that kind of gave a little bit of a clue here by even just saying the word association. But we get the gist that this was not collected from two separate samples, but rather this was collected from a single sample, and we are trying to compare the two categorical variables of what the anger level is to whether they're developing coronary heart disease. And so we want to say that our null hypothesis is that there is no association between the development of CHD and anger, and there is an association between those two categorical variables. Okay, the only other thing that I just want to mention here is we'll go ahead and fill in the name of the test down here for N in phantoms. This would be the chi-square test for independence. Okay, you could also call it the chi-square test for association. And then just briefly here, I just want to make sure that we are all comfortable with the degrees of freedom. Number of rows minus 1, this would be 1. Number of columns minus 1, that'd be 2. Degrees of freedom on this problem, 2. Okay, let's take a look at the next page here. Which chi-square test do I use? It says here. So we've been reinforcing this, and we've been told here that both of these tests really start with two-way tables of observed counts. Okay, they do. They both start the same. In fact, it goes on to say here that even the way that you calculate chi-squared, degrees of freedom, p-value, all that is the same. Okay, however, the question that these two tests answer are very different, and that's because the null hypotheses vary differently. Now, what I would suggest is a little bit easier to distinguish between whether you should be doing the test for homogeneity or whether you should be doing the test for independence, rather than focusing on the question that's being asked. It's much easier to look at how the data was produced or how it was collected. Okay, so we're talking about whether it's from two or more independent random samples or treatment groups being assigned. Okay, that's our chi-square test for homogeneity versus single random sample where we're comparing two categorical variables. That is our chi-square test for independence. Okay, we know that in this box below, this is how we started out this section, which was kind of a summary here of each of the three chi-squared tests and how those hypotheses are drafted. We have difference, no difference for homogeneity versus no association and an association for the chi-square test for independence. Okay, add this note here if you would. When we're talking about homogeneity, it's really two or more, but two samples are taken. Okay, and once again, this for both of these tests, it is the exact same chi-square test. That's how it reads on the calculator. Same degrees of freedom, same way you calculate the expected counts, and it's often presented as a two-way table. But different hypotheses. Okay, that's the difference there. Okay, so our last page on these notes didn't really tell us how this data was collected here. It says we have an article in the Arizona Daily Star. This was from April 9th, 2009. It included the following table. So clearly we can see this is, at least a two-way table. We've got stuff happening here in rows. We have things happening here in columns. Looks like we've got ages across the top. We're comparing how these different age categories, those users, whether they're using social network sites or if they don't use those online social network sites, okay? Suppose that you decide to analyze this data using some type of chi-square test. However, without any additional information about how the data was collected, it really isn't possible to know which chi-square test is appropriate. So it says here, explain though how you would know that a test for goodness of fit is certainly not appropriate for analyzing this set of data. Okay? Now the chi-square goodness of fit test is only when you are comparing one categorical variable in one population. And we can see here, you could make an argument at least that there's either two categorical variables happening, age and then whether they use social networks or not, or you could argue there were two populations that a sample was being drawn from. One population being those who use the online social networks, and then the other population being those who do not use it. So there's definitely one of these two things happening, either age and use of social network or not use, or two populations. Okay, so that kind of eliminates the chi-square goodness of fit test. So then it goes on down here in part B, and it says describe how these data could have been collected so that you would use the chi-square test for homogeneity. Okay, now remember, this is the test that you would use if you were drawing out two separate samples. Okay, so we would say something like, well, if they surveyed from two separate populations, and I'll go ahead and define what those two populations were. It would be those using social network sites, social network, and those not, okay? If they collected it in that way, it would definitely be the chi-square test for homogeneity. Now this last part down here, part C, is asking, describe how the data could have been collected so that you would be using the chi-square test for independence. Well now, if I look back up here, this has to be only one sample. So if that were the case, I would assume that they would have just pulled 1,084, maybe like U.S. Adults, and then from those adults, they would split them into these categories by age and see how they fell also into these different social networking sites. But it would just be one group. So we could say, if we were going to do this, it means that they surveyed one group of 1,084 people. And from those, what they asked them is they measured, basically they had to say, this is my age, and they measured their online social network use. Okay, so that means then this would be a more appropriate test. Okay, a few problems here for you to wrap up chapter 11 on chi-square tests.